Good morning, and welcome to part 5 of Python for Biologists. I'm really glad to see you guys here, and today, as more students trickle in, we will probably have the door opening and closing a few times, but that's what happens when we have a citywide protest. So, welcome to day 5. We are going to do a little bit of intricate thinking as we discuss data structures. The Python language has several data structures that we're going to be using as a basis for plotting, and so I want to try to discuss the differences among them. We're going to, as I said, do plotting using matplotlib, and that's going to require that we install a new library. So today we'll talk a little bit about pip, which is a utility to enable us to add libraries to those that are installed along with basic Python. And finally, we'll discuss making the bar plots themselves in the matplotlib pyplot library. It's a very standard one. Okay, so we're going to be starting with pip. Pip is a handy little tool. You can access itself on the command line, but in this case, we're going to use it by calling it with the Python shell itself. So pip itself will always check to see if there's a newer edition of pip than what's already installed on your laptop. So if you don't have the latest version of pip, you can be sure that the software will remind you about it. So you can see that this first line, python-m pip install-u pip, will update the pip installer itself. Once you've done that, then you can go ahead to install the matplotlib by a very similar command, but here specifying matplotlib is the one to be installed. Now on this laptop, I have not yet installed pip. The examples I tested on a different machine. So I'm going to open up my command prompt right here. I always like to be in the directory where I keep all of my files, which is on the root directory called UWC Python right there. So if I take a quick directory, I see today's stuff. Now I want to run the pip command within Python. So that's python m pip, just like it says here. And I'm going to specify that I want to update the pip installer, itself. Install-u, update if it's already there, pip. Okay, and we see that that one is already up to date. I tested that one this morning, so we don't have to re-download that. But I now want to run the matplotlib installer, so I'm just going to change that last part to matplotlib, just like that. And at this point, it's going to have to connect to the network and see if there's a version of this software available, because at the moment, I don't have any installed on this computer. So we can see that it is connected to files pythonhosted.org to download that library, and is downloading a support library for it as well. CP37M, and here we go, keep going, NumPy, oh my goodness, look at all this crazy stuff. So it's got a few dependencies, which is to say that when you need to install matplotlib, you're not installing just matplotlib, you're also installing all the stuff underneath it that is required for it to work. Okay, so it didn't like something about my path, the F2PY business, but I'll bet that that software now reports itself to be installed. Yes, successfully installed Cycler, Kiwi Solver, matplotlib, NumPy, PyParsing, and Python dateutil. So that's quite a bit of stuff that got thrown in there. I asked it for one library, and I got 1, 2, 3, 4, 5, 6 of them. So that's necessarily going to happen when you install a lot of libraries. They won't install themselves unless all the things they depend on are also installed. Okay, so that's something that we just did with the python-m pip, which is to say calling pip to install or update matplotlib. So that's now in place. All right, now I believe last week we talked about the dict or dictionary data structure. This is a structure where we have named fields that represent, that are called keys that are associated with values. So I have a data structure here titled myCD. Within it there's a key called title, and it has the value Nevermind. It has the key artist, it has the value Nirvana, and it has the key year, and that's a numeric value, 1991. So you can access the value for an individual key by saying myCD, in this case, supplying the key year. So the reply to this is that this year is set equal to 1991. That's a dict. Frequently, we're dealing with functions and structures that may have unfamiliar returns for us. And so I wanted to talk about how we can determine the type of a value. So in this first case, here I am on the left, I'm giving an example of something I might type in the Python interpreter. So having started Python, I can say, what is the type of something called string? It is a type, it is the string type. If I do the type of 5, it reports that that's an integer. What happens if I do type 5 divided by 2? Did you see what happened there? I gave it, the fonts are not really huge, but can you read them okay? You have young, sharp eyes, but that would be difficult for me. All right, so I've asked it to divide an integer, 5, by another integer, 2, and the result of dividing one integer by another integer is a float, because 5 divided by 2 is not a round number, right? So if I were to say type of 6 divided by 2, I get the same result. Division as an operator gives a floating point number even if you start with integers. Just an odd fact. Okay, so we can see that with basic data types like this, we can get useful information about what kind of result comes from it. But I would point out that we frequently want to deal with more complex data structures in this light. So if we had created the myCD object by the code that appeared in the previous slide, the software would report that it is a type dict, dictionary structure. Where does it say that this should be created as a dict? Does it say explicitly, I'm a dict? It does not. In this case, it has to do with how we defined it. Those colons are a giveaway that we have key value pairs, and these curly braces are the other flag that we're creating a dict object. What's that?
And commas.
Yes, and the commas between the key value pairs, that's true. Okay, but that's not the only complex data structure we might use, is it? So we also have things like standard lists. So I could say my list equals square bracket 4, 5, 6, 7, like that. So what happens if I say type my list? It recognizes that that is a list data structure. All good? But I would point out then that if we look at I didn't actually include the text here for. I'm going to grab the text off of this slide and. Here we go. myCD. I'm going to just grab that. Okay, it's not going to let me do that. I'm going to come here and grab that text out. And I'm going to just paste that in here recklessly. Okay, myCD now exists. We see that? So what is the type of myCD? This is a dict. All right, so my list was a list, but myCD is a dict. You can see that they have different kinds of ways to report the contents of these objects. myCD is shown with those squirrely braces, the curly braces, and just as it was defined, it has the key value pairs separated internally by colons, and between the different key value pairs, we have these commas. All right. A list, however, is a different kind of data structure, and it's represented. Its type is indicated by its report style: square bracket, 4, 5, 7, 6, 7. Those are the internal values of the list being separated by commas, and the entire list is surrounded by square brackets. So the software has some consistency with how you would create the value of one of these complex data structures and how they are reported to us. But if you ever forget what the type of the thing is, you can always just say type. Okay, so very helpful feature. I'm going to return to the slides here. Now I've done something wildly complex on this next slide, and I want to try to walk through that carefully. So we've already mentioned that dict uses the curly braces to define its internal, its whole data structure. We've already seen that square brackets are used for lists, but I want to note that there's another kind of thing that we can do here too. You can see that this object is called a list. Why is it called a list? Because it's a list of this first parenthetical stuff, the second set of parenthetical stuff, and the third set of parenthetical stuff. So we have a structure within a structure here. The list is a list of pairs of things. So we have a key A matched with a value 7, a key B matched with a value 3, and a key C matched with a value 1. The list has 3 items in it, but each of those 3 items is a pair of things. So I want to note that in this very next set, I've done an index against that. So I started with a list of these 3 parenthetical expressions, and here I'm specifying that I want just the second item from that list. To show that again, remember my list over here had 4 values in it. I can say my list, and I want the second value from it. Okay, why did it return 6 there? Exactly. Computer programmers start counting at 0. So when you specify the second element of an array, it's going to give you the third in the series because the first one is 0, is the 0th. So if you want the first element in that array, you need to specify mylist 0. Okay, but we had a more complex definition here. You see that? Again, I'm going to grab the text out and throw this into a variable so we can play with it. All right. So I'm going to say now mylist equals whatever that nonsense was. Okay, now I had some extra stuff on there. You see those parentheses? The outermost parentheses aren't actually necessary. It's still mylist. If I create it this way, it is seen as a list. If I create it without the parentheses, it's created just the same way. It's still a list. Yep, sorry. Case matters, so if you leave off the capital L, that's going to throw an error. Okay, great. So my list, can I do a length call on this? I haven't actually checked this function. Let me make sure this exists. Ha, it's not. Okay, that's fine. Is it mylist.length? No, it is not. Okay, well, never mind me. Okay, maybe it's size or something like that. Doesn't matter. All right, so what happens if I ask the first element of my list? So my list's total length has these 3 elements in it, A7, B3, and C1, and each of those pairs exists as one item in the list. So in effect, it would look like we have a list of lists, doesn't it? Sort of. Where A7 is a list of 2 elements, and B3 is a list of 2 elements, and C1 is a list of 2 elements. But that's not actually technically what's going on. If we use type, we can detect that the list is not a list of lists. It's a list of things called tuples. Tuples. When you have a data table, like in a database, maybe it's a list of surnames for people enrolled in a class or something like that. Each row of data is called a tuple. So they've used that name here. Instead of creating a list of lists in this case, we have a list of tuples. Each tuple has a letter and a number associated with it. Okay, so I realize that that's maybe a little bit into the weeds, but it's really important for you to know about this stuff to explain some of the code that we ended up using today. All right. One of the really valuable things about having data in a dict structure or a counter structure, because I hope you remember counters are derived from dicts. So all the things you can do with a dict, you can also do with a counter, is that you can return all of the keys associated with it, and you can return all of the values associated with it. You can also have it just kick all of the items back to you, and those are the keys, values, and items features. So if I pop over here, I had the myCD object. Remember, that was a dict, so we could say myCD.keys, and we see that it's returning just the first part of each of these pairs. The key, but not the value. The key, but not the value. The key, but not the value. I can handle it the other way to report just the values, but not the keys. So I get nevermind, but not the title, but not the what nevermind represents. I can get the word Nirvana back, but not the label that came with it, essentially. And I can get the number 1991, but not the fact that that was associated with year. Okay, that's going to be really valuable when we try to do plotting, because one of the things we need to hand to our pyplot function is the list of the categories separately from the list of counts associated with it. Okay, so if we are building our bar plot, we're going to use, first off, because we're using a function pyplot from matplotlib, we must import that for use in the software. If you have not already installed matplotlib via pip, that import command would fail. It would say, well, you can't import a library that's not installed. So we must do that. Here I've created simple, which is a dictionary structure, and I'm defining it by feeding it a list. You remember the square brackets always indicate a list. So here, when I defined myCD, I did it with the curly braces. Here, I'm instead creating a list of things and chucking that into a dict, which is a little rude perhaps, but I wanted you to be aware you can do stuff like this. I am going to create a dict that has 3 keys in it, one called A, one called B, one called C, and it's going to have assigned values to it, 7, 3, and 1. Then I need to create an object that represents my bar plot, which is the bar function, or the bar constructor from pyplot, which is part of matplotlib. And I'm going to pass it the keys from simple and the values from simple. Once you've created the object, though, most people will want to show the plot, and that is a method associated with pyplot. All making sense so far? I realize I did a lot of gyration there between dicts and lists and tuples and things like that, so that may not all be clear. I hope that the examples will make sense if you have a chance to review this. So I have created this code in the tinkering file here. So you can see that up at the top, I'm going to import collections, because later on I'm going to use counter. And I've imported just the pyplot part of matplotlib. You see that dot there? Right, that implies that I don't want to import all the things from matplotlib, just the pyplot parts. Okay, so let's try running this first bit of code. I'm going to just grab this. Remember, I have to have my Python is actually running, the interpreter is here. Now I'm going to paste in all that stuff. And look at that, just like that, I've got a bar plot. Now, this is working on a lot of defaults at the moment. You can see that the window is titled Figure 1 because I didn't provide another name for it. It's using blue bars, but I didn't tell it to. That's just the default coloration it uses. I didn't tell it how to format the axes, but it had some font it decided would be just fine for a default. And it has these the vertical scaling that's been determined automatically. I didn't tell it to stop at 7, but it looked at the data and said that was the highest value in there. So there are lots of things we could have customized here, but we didn't. We're just using kind of the simplest call that we can for the software. Okay, we also see that the software behind the scenes has not continued. I can't come back here and start typing. What I need to do is close this figure in order to do that. All right, so let us start by looking at this object simple that we created. First off, it was created with a dict constructor function. You see this dict parentheses business? That's the function for creating dict structures. So it should be no surprise that when you run a type on simple, you get back its class dict. All right, if you simply type the name simple and hit enter, you can see it reporting its values. So this is a little odd, and I want to emphasize this. I'm going to create another variable called what we fed it. Sometimes I get whimsical with my names. And here I'm going to grab everything between the square brackets, well, including the brackets themselves. Okay, so what response am I going to get from asking the type of what we fed it? Does anyone recognize that structure? What was that?
It's a list.
It's a list, right, yeah. So when I provided the information for defining simple, I did it in the form of a list. And it's a list that has elements to it that are compound. So the first element of what we fed it is A7, the second element is B3, the third is C1. Those individual items are not lists. So if I say type what we fed it to, we see that that's a tuple. Okay, so I created a list of tuples because it was a very compact way to define all the content of this dict that we wanted to create. In any case, simple was built by running the dict function on what we fed it. Oop, gotta use my caps right. So in this case, the software was clever enough to know how to deal with a list that it was handed in order to create the dict data structure. Grand. So now that we have simple, we can see that we want to grab out the information from inside simple. And we did that using simple.keys and simple.values. You can see that one of these is a dictionary keys that is a list of A, B, and C, and that the dictionary values that popped out are a list of 7, 3, and 1. Those are key inputs that you have to, those are the necessary inputs for creating a bar plot. So if you were generating a histogram and you had already accumulated counts of something, you could pass that information by passing the label information, the keys, to the plot function, and the counts that came out as the values that come along with it. Okay, and then finally, we actually call matplotlib on the keys and values, like that, and then matplotlib pyplot show works just like that. Now there are many other functions, that many other parameters that we can set about the plot, but this will be just fine for now. All good with that? All right. I understand that data structures like lists and dicts and so on can be bewildering. That's actually a second semester class in the computer science program where I got my degree from. So. We haven't even talked about some of the more amazing things we can do in computer science, like balanced search, binary search trees and things like that, hashes and all that. These are relatively accessible data structures that I felt everybody should know something about lists and why dicts are valuable in the case of bar plots. Okay, so this is all that we have for the slides for today. I also would like us to spend a little time with this tinkering code that I have. Okay, so you can see that I imported collections along with matplotlib pyplot. But we didn't actually use it up here, did we? There's no counter to that. So just as another exercise, I would like to create a counter, initializing it with this string, DDDD, UUU, GGGGG, ABB. Everyone sees that? Now, why am I passing a nonsense string like that to the constructor for counter? Let's just run the code and see what we get out. Okay, so if I say counter example, I can see that I've kicked out a digest of that string that gives me valuable information about it. G was encountered 5 times, D was encountered 4 times, U was encountered 3 times, B was encountered 2 times, and A was encountered just once. Now, I think you remember that last week when we looked at the character composition of the sequence database, we had a surprise guest in there. It counted how many times the new line character had been seen. In other words, it hit the end of a line of sequence. That wasn't very useful to us. So I want to note that we can edit counters by specifying particular keys that we're not interested in. So you can see I'm using the delete command to excise from counter example all things associated with the letter A. So if I run that and then revalue counter example, you can see that it still has the G's, the D's, the U's, the B's, but the A key has been excised from this. So we're going to use a trick like that to get rid of the new line characters that we read off of the FASTA file. I just wanted you to know about that because it is possible to modify these counters. Okay, so we're going to look at some of the special functions we can use as we manipulate counter data. I'm going to just copy that whole block of code here. Okay, so we started with a counter that included G, D, U, and B, but we had already cut A off of it. If I ask what is counter X, the example that we created there, it remembers that this was created as an example of collections.Counter. That's not too surprising. And if you look up collections.Counter, you'll see that it inherits from the dictionary structure. So commands that dictionary follows, so will this. Now we want to manipulate these data a bit as well. We're going to add some sorts to it. And so one of those is created by the most common method that belongs to objects of this type, of counter type. So we can execute a most common method, and what it replies with is a list. It doesn't reply with another dict, it replies with a list. We also could run the items command on it, and it produces an item of type dictionary items. Okay, and finally, we could use the sorted command to deal with all of the items that are stored within the counter. That too will produce a list. So what do these things actually look like? So we said already, counter X looks like that. Counter X dot most common, got to get my caps right here, changes this, doesn't it? Well, it doesn't in this case because it's already sorted. But if these values were not previously sorted, most common would replace them with the most common element first and the least common element last. I want to note, though, that the value of counter X is not the same as the value of counter X dot most common. What's changed between these two? The value of counter X is not the same as the value of counter X dot most common. What has changed between those two?
The second one listed, it gives us a list.
It gives you a list, exactly. So we see that the first one remembers that it's an object of type counter. The second one is not an object of type counter. It is a list of items. Good. All right. There's also the option of calling counter X dot items, the items method, which is going to report a series of dictionary items. It is possible to run a function on that will sort these values based on key. So you see that when we did counter x.mostCommon, we got a list of tuples that were in order of the most commonly seen element to the least commonly seen element. That's different than running sorted. Sorted is alpha on key. So the letter B comes before D in the alphabet, D comes before G, G comes before U in the alphabet. Okay, but again, it is a set of items that we can work with. All right. So when we look at this code, we're going to try to take the result of sorting on most common or sorting on alphabet and store that in a dictionary. So you can see that our frequency dictionary is going to use the output from .mostCommon and shove that through the constructor for a dictionary. The alpha dict, on the other hand, is going to run the sorted function in order to alphabetize by key, give that to the dictionary constructor, and that should create this object. So let us see what results from that. Okay, so we created two new objects there. One was the freq dict, and the other one was the alpha dict. All right, so before we had square brackets denoting that these were items of type list. These are surrounded by curly braces, and curly braces are the indicator of dictionary structures, exactly. And that means that we can run commands like keys and values on these objects. And that's necessary for making this really simple to dump into a bar plot. Great. So we can use the same strategy as we did before to plot this information. Okay, so this is the data as it was stored in the counter x. You can see that we're using counter x as the object on which we're calling keys, and counter x is the object on which we're calling values. Now I want to change this to be freq dict keys and freq dict values. You see what's happened? The ordering of the bars has changed. So very frequently you're going to want to change. You're going to want to sort your plots in some way by most common or alphabetical ordering, and you can compel the information in your counter to be formatted in a different way by changing back and forth between these formats. Okay, so that's the code example. I know that we've done a whole lot of shuffling between these types, between these lists and dicts, and of course the counter object itself. But hopefully that will help you understand a little bit of what the code is trying to do. So I want to now move over to the goal 5 code. This should be something you downloaded from the server last night or this morning, I think. Okay, so you can see that we've changed just a few things. We already had sys and collections as part of our imports. Now we've added matplotlib pyplot as one of the imports. If you don't install that code via pip, this script will fail there. Okay, we're now on version 0.5 of the sniffer. Oh dear, I didn't fix that code up the top. I'll need to change that. But down here, we see that we're still updating our letter counter only when we get to a line that contains sequence. That was code that we changed last week. We can close the file when we're done with it. That's always a good behavior. So now we're finally into the new code that comes along with this week. So we have used the delete function in order to delete operator to remove the \n characters that were created by letter counts. If you recall, those represented where we hit the end of a line in a line of sequence. So we can strip that stuff out. Now we need to create a dictionary that's based on the letter counts, but here we're going to use the most common function, or the most common method. That most common method will sort all of the different keys that were in letter counts based on how frequent they were in this database SNF. We will also use the sorted function in order to sort all the different keys within letter counts based on their alphabetical ordering of the keys. These don't return dictionary structures, but the lists that they return can be shoved into the dict constructor, and that will create the freq dict and alpha dict dictionary structures. And then we get to the part where we just report. Last week we were already reporting how many different accessions there were within the sequence database. We're going to create a plot of the counter just as it existed in the first place, just to help us know that it mostly makes sense. But then we'll do a frequency sorted list and a plot associated with it, as well as a plot of the alphabetically sorted list. Okay, so let's see how this all runs. Now I need to exit Python. I'm back on the command line. I see that I have lots of different programs within here I can run, but the one I'm interested in is today's code for goal 5. There we go. Remember, I can't just run it by itself, because if I do that, it's going to say, you didn't give me a database to work with. That was one of the very first things we did. So I'm going to repeat that command, but this time I'm going to specify that I want the Mycobacterium tuberculosis database. Okay, so let's run that. So we see that the software does not execute all the way through. It stops as soon as it has produced this plot for us. That's because we use the show command. I would note that having it on screen is nice, but it doesn't quite make the figure for your paper. And if you're writing a paper, you're probably going to want to save the image. You can see that this menu down here gives you the option to do just that. So creating a figure like the one that I included in the slides today is really quite easy to do. So these are the counts as produced in the counter object, the letter count object. You can see that \n is no longer included here. That's because we deleted it from the counter before we produced this image. If we'd left that line out, we would see how many times we went to the start of the next line. This is not necessarily a very easy way to perceive the data. Therefore, we are going to skip past this one and continue on to the one based on freq dict, FREQ-DICT. We see that when we ran the most common function on this, we got back the result that alanine was seen 177,000 times in this database, whereas something like cysteine was seen only 11,800 times. 177,000 is quite a lot more than nearly 12,000, isn't it? So visually, I find it's a lot easier if we can plot these data for people to interpret them. So we see that alanine actually won by quite a large measure. And then down here at the bottom, we have M, W, and C. So would you say that these numbers behave as expected, or would you say that this is a very unusual distribution of letters for the sequence database? People don't have an opinion about that one. Okay, well, I would say that when we look at something like the Swiss Prot release notes, we will typically see that letters like L and V are very frequently used. They're some of the most frequent amino acids in the broad swath of sequence databases. Here we see that L and V are ranked 3rd and 4th, so that's not very unusual. The alanine having such a high result is a little surprising to me, but it's not hugely unusual. On the other hand, if you look at the low end of this, you see something that is very typical of sequence databases, which is that C, W, and M are very rare amino acids. Remember that cysteine takes part in disulfide bonds in protein sequences, in protein structures. So having a whole bunch of extra cysteines is probably not a very adaptive thing to do. Where you need a cysteine, you put a cysteine, but you don't want to have a bunch of extra cysteines in proteins. Tryptophan, W, is a very large and expensive amino acid to construct, so using it when you need it is appropriate, but not a whole lot of extra times. And methionine is also kind of a special purpose amino acid. After all, we most typically see it at the N-terminus of a protein to mark kind of the start of the start codon of the translation. So that's this frequency distribution, I would say, mostly coincides with what we would expect of the frequencies of the amino acids. Sometimes it's easier, though, to have an alphabetical sorting. So if you were interested in knowing how many times N, asparagine, showed up, it's easier to find here than in the frequency-based dictionary. So because these are alphabetically sorted, it's very easy for us to jump directly to the asparagine. So I think that it's not the case that there's only one true way to sort all the information that comes back from this software. And being able to provide different looks to the data for your users is actually quite helpful. One of the other kind of odd things about this particular display is that alphabetically we've put A and C right next to each other. And if you remember from the frequency plot, alanine was the most common amino acid in the database, and cysteine was the least common. So it's kind of an odd juxtaposition. All right, having clicked X, the software reports all done, and we're dumped back to the command line. So I think I worked you a little bit today. All that work with data structures was a little confusing, but you rallied well. I think it's valuable for you to see that you can pass a list that's formatted in this tuple format to a dictionary constructor and get a worthwhile dictionary out of it. That kind of manipulation is one of these things that we just have to be able to do from time to time. But that's the show for today. When we come back next week, next Thursday, we'll be having our final session of Python for Biologists. In this, we're going to move away from using generic collections or generic modules, and instead use a module that was designed explicitly for use by biologists who are trying to deal with DNA and amino acid sequences. And I think you'll see that that's actually very helpful in a lot of the things that we wanted to do. We will also take a look at NumPy, which is a very useful library for doing all kinds of mathematical operations. We've been looking at just counts so far, and that's obviously a pretty easy thing to get your head wrapped around. But sometimes you need to deal with floating point numbers or compute medians or modes or whatever. NumPy is really good for accelerating that. Okay, well, I will see you next week, and we will continue on with our final session in Python for Biologists. Thanks.